this. Okay, hey, 10.6, Systems and Parallel Lines. Welcome back. We want to look at your vocabulary. It's coincident lines. What does that mean? And with parallel lines, we have two situations. If they're parallel, they either have no solutions in common or all solutions in common. If they have all solutions in common, that means they're the same line, or they are coincident lines. It's not a coincidence that I mentioned coincidentally. So we've got systems. We could have, for linear systems, 0, no solutions. We could have one solution, or we could have an infinite number of solutions. The idea with parallel lines is we say they go in the same direction, but they will never overlap. If they're horizontal or vertical lines, well, all vertical lines are parallel within their category. But oblique lines, to be parallel, they have to have the same slope. Hence this property, slope and parallel lines property. If two lines have the same slope, they are parallel. The question then, if you know slope, is do they have an infinite number of solutions or no solutions? Let's take a look at what we can do next. Okay, example 1, solve the system. We've got x plus 5y equals 7, and a negative 10y equals 2x minus 14. Now again, one way we could do a solution to a system like this is to plug it into our calculator and graph it. We could solve it using a CAS, or we could do it by hand, which is what we're going to do right now. I want to put this into slope-intercept form. Never mind. I'll go with standard form. Looks easier. And so I'll have x plus 5y equals 7. And I'm going to subtract 2x from both sides of the equation 2. Minus 10y equals a negative 14. So I've got it rewritten in standard form. And in this form, it's easier to see, I think, what's going on with this problem. Let's go ahead and run through our solution, though. To get one, I'm going to have to, I think, take equation number 1 and double its value and then add those together. So that'll be 2x plus 10y equals 14, and next equation is 2x minus 10y equals a negative 14. I add those together. I get 0 plus 0 equals 0, and I get that 0 equals 0. What this means, since I reach a true conclusion that for any value, for any xy combination that I choose, that if it works for one, it will always work for the other one, so that all solutions are true, which means these are parallel and coincident lines. I could see that by just simply looking at the two equations. I can see that equation 2 is simply twice equation 1. If I put it into slope-intercept form, I'd have, let's see, 5y equals opposite of x plus 7, and a negative 10y equals 2x minus 14. Okay, now I need to deal with the coefficients. So y equals a negative 1/5 x plus 7/5. That's for our equation 1. For equation 2, I have that y equals a negative 2/10, which reduces to a negative 1/5 x. Negative 14 over 10 reduces to 7/5. fifths, and over a negative 10 reduces to a positive 7 fifths. And we see that we can simplify both of these to give us exactly the same equations in slope-intercept form. So these are parallel and coincident lines. Let's look at our next problem. Find all the solutions to 12x minus 30 equals 12 and 8x plus 20y equals a negative 8. So happily this is in standard form already. I can look for some kind of a solution here that will allow me to come up with an answer. Let's see. Well, I think I could multiply through by a fraction. Let's try that and see. If I got equation 1 and equation 2, and if I multiply the equation 1 by 2/3, I think then when I add them together I can reach a conclusion. So I'm going to take 1, I'm going to multiply so equation 3 is 3 goes into 12 4 times. 2 times 4 is 8, so that's 8x, minus 3 goes into 30 10 times. 2 times 10 is 20, minus 20y. And we already determined that this was 2/3 times 12 is 8. And then we have our negative 8x plus 20y equals a negative 8. We add them together and we get another situation where we have our 0 equals 0. And all solutions, right? We reach a conclusion that works, that makes sense. Therefore, all possible values will make sense, and they are coincident lines. When are they not coincident? I mean, when do we get to something where they're parallel but they don't equal? In that case, what we would get to would be no solutions. We would get to a kind of a nonsense answer with these calculations where no possible solutions exist. Okay. And lastly, description of the system. We have two intersecting lines. That means there's one solution. The slopes are different. Two parallel and non-intersecting lines. There are no solutions. They have equal slope. One line is parallel and coincident. There are an infinite number of solutions and the slopes are equal. Well, that's it for 10.6. Be looking to help you out on 10-7 and see you on the next lesson.
Right.